Thank you for joining this webinar from Five9 Software. In this session, we're going to be talking about achieving PCI and DSS compliance for the Microsoft Cloud using Five9 Cloud Security. Our presenters today are Morgan Holm, VP of Product Management, and Alex Karavanov, our Director of Solutions Engineering. Morgan has been with Five9 for about 1.5 years and runs the strategic direction for our product, design, and development. Alex Karavanov leads our technical team with regards to solution engineering, development, and working directly with our customers. As part of this platform, we have several different features that we want to make you aware of. We do have a live question section, so if you have any questions as we go along, please type them in. We'll be happy to address them. We'll be also asking you several poll questions throughout the event to better understand who you are and your current usage of different security software. And additionally, we have several handouts that you may find interesting, which not only include the presentation, but also some other useful resources, white papers, and other components all around PCI DSS compliance for the Microsoft Cloud. With that, I'm going to turn it over to Morgan.
Thanks so much, Simon. We'll go ahead and review what we're going to cover here today. I'm going to do a brief introduction on who Five9 is, go over the PCI DSS standard for Microsoft Cloud environments, talk about compliance for service providers, and how you can go ahead and secure those virtual environments for PCI with Five9 solutions. We'll wrap it up with a demonstration and look at some of the resources that we provide and other industry resources that you can use to help achieve PCI DSS compliance. So Five9 was founded back in 2009 with a strong focus on protecting and managing the Microsoft virtual infrastructure. We're headquartered in Chicago, have staff in 24 regions worldwide, and we have a technical evangelist program that includes 17 Microsoft MVPs. We have around 100,000 Hyper-V users globally, and this represents companies of all sizes from very small to the extremely large. We're really a leading solution provider of that security and management for applications for Hyper-V. And this is through our various different solution sets. We have our cloud security solution, which we'll primarily focus on today. We have a management solution and a V2V easy converter to move from VMware to Hyper-V. So as we mentioned before, there's a global presence. We have people in 24 cities and 17 countries around the globe. Now let's go ahead and talk a little bit about the PCI DSS for Microsoft Cloud. So we're going to go over and review the various different aspects of the DSS standard, and we're really going to tailor this to the Microsoft virtual environment. Basically, the payment card industry, including all the major credit card vendors, got together to come out with a compliance initiative around securing infrastructures for organizations that process credit card transactions, as well as for retailers or end organizations that use it. This is a fairly broad-reaching compliance as compared to many of the other regulatory compliance initiatives out there, because it really covers a very broad spectrum. Others may focus specifically on financial institutions, publicly traded firms, utilities, and only publicly traded companies and the such, but this really covers a very broad spectrum of organizations that both use or handle credit cards. And really it's about building trust for the credit card infrastructure components, because I'm sure we're all quite aware of very numerous breaches that have occurred. Specifically, we can talk and mention about the Target, Sony, Home Depot. You know, those three alone are well over 100 million credit card numbers that have been detected for breach and had fraud committed against them and or card replacements. So really, this is really about helping build your reputation for those credit card processing firms as well as organizations that submit them. and you want to make sure that they can keep the trust for that data and handling it. Customers are increasingly leveraging credit cards to perform both online and in-store transactions as opposed to using cash. And the whole goal of it is to make sure that the security in place at these organizations can help to prevent any sort of breaches around that credit card information. So the PCI DSS standards are really built around these main different sections about building and maintaining a secure network, protecting the cardholder data, maintaining a vulnerability management program, implementing strong access control measures, monitoring and testing those networks where these systems function on, and enforcing that organizations that do this have an information security policy in place that they can measure against it and make sure that they have conformance to that particular policy. We'll go in now and look at those individual sections in a little more detail here. For building and maintaining a secure network, one of the requirements is the ability to go ahead and install and maintain firewall configuration to protect that cardholder data. So this poses some unique challenges, especially in a virtualized environment. Of course, many organizations have moved either to public cloud implementations as well as virtualize their internal infrastructure components, and they're going to require that they protect that information with a firewall. There's some challenges around firewalls from a traditional network appliance standpoint. Those exist on the network, and that doesn't always capture traffic based in a virtualized environment. So you want to make sure that you're looking at a virtual firewall that can see all the traffic in the environment, preferably integrated into a Hyper-V virtual switch so that you can see all the traffic, whether it's destined internal, external, or private. This is commonly referred to as east and west traffic in the virtual host itself, and that's where that network traffic actually never makes it out past the host itself, where it's communicating amongst VMs. Maybe they're part of the same workload and require that information. And of course, you want to see that traffic coming in northbound and southbound is also subject to those firewall rules. The other thing that you want to make sure that you check is, in the case for cloud service providers, is that you have a multi-tenant model. If you're hosting multiple customers on shared infrastructure, you want to make sure that one of those consumers of that service aren't using that as a launchpad to perform attacks on other tenants within that particular environment. The whole goal of this scenario is that so that you can isolate those individual VMs and ensure only the traffic required for the workload is only being allowed through. Another key aspect here is you want to make sure that you automate that protection. What I mean by this is virtual environments are extremely dynamic, and that's the whole, one of the goals of them is to be able to quickly ramp up or scale down resources as needed. A good example would be for a retailer that's bringing up more infrastructure to handle a holiday rush season when there's many more purchases going through than during a typical period set. So as you bring in these new resources and scale up your workloads, you want to make sure that those are immediately protected and offered the same firewall and antivirus protection, etc. Another thing that you can also look at is the ability to go ahead and schedule your firewall rules. That's something else that you should look at. An example scenario there would be, say you're a card processor and at a particular data center you have specific work hours where people are working with those systems and need access to them. You may want to be able to shut down that access during off hours, and again that's about reducing that attack zone or the attack time frame that they could go ahead and come at your system. Another aspect to the secure network is not using vendor-supplied defaults for system passwords. Now this is typically not an issue in the Hyper-V Microsoft environment. It's more targeted at those security or network devices that ship with default passwords out of the box. Most people leverage Windows integrated authentication or Active Directory, and that's going to go ahead and cover off the ability to not leverage vendor-supplied passwords. You're also going to want to implement policies where those users are going to be forced to change their password on a regular basis, all part of a standard password management. The next thing we're talking about here is protection of the cardholder data itself. So this is actually a requirement that looks at both the physical access to the data, where you have a data center that has storage of that credit card information. You want to make sure that you have a control where people can't just walk into the data center, plug in a USB stick or a portable drive and download that information and steal it physically from your environment. You also want to look at encryption of that data while it's at rest. So that's another layer of protection that you can put on top of that to ensure that even while it's sitting there, it's less susceptible to being stolen because it's in an encrypted state. So that's what I would call data at rest protection. The other thing about the cardholder data is as it's being moved around for reporting or processing, you want to make sure that the encryption of that data is when that data is in motion between those systems, that you're not exposing it there as well in case there's any sort of sniffing devices on the network that are listening for that information and gathering it in that manner. So that's about the data in motion encryption. The next part of the DSS standard is making sure that you maintain a vulnerability management program. So under this, you have to make sure that you're using up-to-date antivirus software or programs to look for viruses or malware that may be present in the environment. One of the things here is when you're looking at a virtualized environment, it becomes a bit different than the traditional endpoint antivirus that most folks are familiar with. The reason that these organizations went to a virtual system with running Hyper-V and VMs is that they're trying to consolidate those resources and make sure they get the most use out of them. So an agentless approach is something that you should be looking for there to maintain that performance. Also, another aspect to this is that the scanning, you should be looking for scanning that doesn't need to have that agent side of the virtual machine, because you have the ability for maybe a workload administrator that comes in and says maybe they're having slow performance. They decide, well, you know what if I just disable antivirus or the end users of the system there. When you do it from an agentless standpoint, that security is going to be invisible for them. With this, you also have to look at developing and maintaining your secure systems and applications. So when you implement a solution set inside, you have to also understand whether it does any sort of security checks or integrity checks to make sure that there's no tampering with any of that. For example, on the antivirus side, you want to make sure that somebody hasn't gone in and is attempting to put in malware by modifying the signature database to remove the signatures for the virus or malware that they're trying to implant into the system. So you have to have integrity checks on those AV components to make sure that they're running in a true AV signature set there. Of course, you also, when you're deploying these systems, you can't test or develop on your production environment as well. And that's in case there's any unknown risks that are present in whatever your change management that you're doing, any of or new solution sets that you're putting in. You want to make sure that you isolate that and fully vet and test it before putting it into the production environment. This comes back also to that automatic immediate protection, and that's again to make sure that you minimize that risk. There's no window now where when you're bringing up a new VM in an environment, for example, that is not protected from firewall as well as antivirus. We also want to look at detecting any sort of application level attacks directly on the Hyper-V virtual switch. So you're going to be looking for any sort of unusual activities or specific people trying to leverage different ports and protocols to come in and attack weaknesses in those known application infrastructure components. The other thing that you want to make sure that you're doing on this side is make sure that you're logging and looking at any configuration access attempts. So you have to make sure that the solution set sees, so that if you have an insider, for example, or you have an attacker that's in there through an advanced persistent threat, that they're not going ahead and changing the permissions to gain easier access to that information. Integrated intrusion detection system will definitely help in this approach as well, giving you the ability to see signatures of well-known attack vectors that hackers use to break into these systems. The other aspect to PCI DSS is the implementation of strong access control measures. So some of the subsections under here is the ability to go ahead and restrict access to that data by a business need to know. So that means you basically can't have broad access to that information. If somebody needs to be able to go in and manipulate that data or look at that data, it has to be part of their job description. This is typically covered by Active Directory in a Windows cloud infrastructure scenario. As well as assigning a unique ID to each person with computer access. You want to make sure you're following best practices, like where every user that comes in has a unique ID. So for example, you shouldn't be leveraging any sort of shared accounts to go ahead and perform any management. Again, covered by Windows Server and Active Directory. Restricting physical access as well. This is where you want to make sure that that cardholder data is in a secure location and not just anybody can walk into that data center, so that they could physically walk away with hard drives and or attach USB sticks, portable hard drives to pull information out. Another aspect here is the ability to regularly monitor and test that network. So the ability to track and monitor all access to those resources and cardholder data. Again, this is requirement. It's covered by standard access rights Windows Server, but you also want to look at any sort of anomaly detection and to detect an alert on any sort of suspicious activity. A good example here would be if you're seeing a large amount of data being exported out. It's something that you want to be notified of because it could be a potential breach that you're not aware of, so that you may have to go in and do some protections or try to lock down that information. Or it could be a known activity, say there's a migration to new storage, for example. But understanding when unusual behavior or anomalies are occurring is also critical. The ability to track all of the events and store those in an unchangeable format for analysis is also critical here, so that you understand all the system, what the system is doing, what end users are doing, storing that data set and making sure that it also can't be tampered, so that a hacker's not trying to cover their tracks by modifying those logs or deleting them, for example. A common thing here to help address this and to help make the forensic analysis easier is integration with a centralized logging system. OMS is a new one coming out from Microsoft that a lot of our customers are very interested in leveraging. Syslog is another very common tool for that security event and intrusion management systems, so that you can put together the whole picture of how data comes in and out of the systems. Another aspect to this section is that you need to regularly test those systems and those processes. So by going out and collecting those network statistics, you can see the overall traffic, packets, packet size, etc. You want to understand what's going on in those systems. You want to also track each VM to, again, look if there's any sort of deviation from their normal activity. And you want to have some automated alerting. It's not something that you want to discover later on looking through the logs. You want to be notified in the case of an anomaly being detected in the environment. So that comes down to intrusion detection. You want to look for integration in an intrusion with intrusion detection. And you also have to successfully pass penetration tests. Maintaining of an information security policy. So the DSS standard indicates that you have to go ahead and create a security policy for those environments that have the cardholder data systems or cardholder data itself, and make sure that that policy is in place, it's well known in the environment, and that you can go ahead and prove that you're testing against that policy and that those processes are being followed within your environment. And that's for both internal and external audits. PCI DSS is moving out to 3.2. There's some key dates here that we want to make everyone aware of. The standard has been released as of April this year. It has some self-assessment questionnaires. In October, it will officially take place, but there's actually a fair amount of time before the new requirements that are being mentioned here will take effect, where anything that's new will be considered a best practice as of October 2016. Most of them will be a requirement as of February 2018. A lot of organizations will not wait until the February or later in that 2018 time frame to go ahead and actually make those best practices requirements in their environment. Again, because of the rather large amount of credit card data breaches that we're seeing, they're going to want to be able to make sure they follow those recommendations much earlier. Some of the other changes here that we're looking at is for SSL to TLS migration. That's going to be a requirement as of 2018. A new one here is multi-factor authentication. Prior to 3.2, you had to have two-factor authentication for non-console access for administrators to the systems. Now that's being changed to multi-factor. So two-factor is basically the minimum requirement, and it's no longer for remote access to those systems. It's for all administrative access to that cardholder data environment. Another thing that they're really pushing on the new 3.2 is that typically when you're looking at a regulation before, many people were striving to meet the requirements of the regulation on an annual basis when they're going to be analyzed for it or audited against. Maybe some of the organizations were doing it for twice a year, but now it's more of an ongoing process where you have to maintain this on an ongoing basis as opposed to just reaching those levels for 1 or 2 times in a year. Okay, so this is compliance for service providers. Alexander will go ahead and take over at this point.
Thank you, Morgan. So in this section, we are going to speak about compliance for service providers. And the reason this topic is so important is because in service providers world, there are 2 types of responsibility that is split between service provider and end user and the customer. Before we go into deep dive there, I would like just to mention a couple cases when compliance wasn't followed as it had to be, and it resulted into data loss and data breaches. And you know, these cases were very, very loud, and Morgan actually mentioned one of them that was related to Sony, several years ago, and they were running their services, and these ones got breached, and it did cost them around $169 million in lawsuits, and make sure that they do all the tests and all the proper security measures. Evernote a few years ago lost 50 million records, and some of their customers started receiving phishing emails, fraud emails that got stolen. So luckily they were able to survive that, but quite a few customers suffered, and of course that was a very bad state for the company, and they lost quite a bit of trust. So in service providers world, it's very important to maintain customers' trust to make sure that business is running safely. So, and of course, customers' trust is based on the security measures that currently exist inside the infrastructure, and making sure that no security incidents really happen. And lately, one of the major, probably major security incidents that was happening and that got mentioned as a service provider threat is related to internal events and internal threats coming from malicious customers. So these are the ones that are being currently used a lot, and the reason for that is because once service provider goes outside the business, hackers tend to try to buy the virtual machines, to run the virtual machines from this particular service provider in order to attack its customers. And in that case, once they're inside the infrastructure, the perimeter protection is not existent anymore, right? So there are only internal security measures that got taken, and this is where hackers leverage that in order to try to steal data or attack other customers. And of course, every single service provider has to be protected from that, and that's why it's important to stress your attention from perimeter protection, which is, of course, is the major one as well, but internal protection has to be very tight, and especially when you're about to provide any services related to PCI DSS compliance that we're discussing today. So once you have this, and once you passed all the requirements, as a service provider, you can offer more services to a wider range of customers. And I should also tell that service provider term actually belongs not only to cloud service providers, but sometimes you may be running a internal cloud, right, for internal departments, and that's also going to be a service on self-service portal that helps you combine multiple departments in one data center. Also, if you're a government agency and if you're building a specific service for other agencies, that's also considered to be a service provider environment that still requires the compliance regulations to be met. Also, every single tenant, every single customer expects that his privacy is going to be maintained at the maximum level, and whenever we enforce protection, this has to be unnoticeable for absolute majority of the customers. Make sure that they don't feel any performance degradation, because customers tend to be very sensitive whenever speaking about security and performance. So you need to make sure that you protect your environment, you protect your business, being a service provider, but you also need to make sure that customers don't have the way to disable protection or suffer from any performance difficulties there. So with that, focus on agentless protection really helps to maintain that, and immediate and security enforcement for newly created virtual machines is something you would look for to make sure that every single virtual machine that spins up in your environment, in a service provider environment, gets automatically protected. As we go through the PCI DSS requirements for service providers and their customers, you would see that it is a little bit different for infrastructure as a service, platform as a service, and software as a service type of services. So for infrastructure as a service, majority of responsibility is shared, but still there are more levels that have to be controlled by a client and explicitly. So whenever we're talking about PCI DSS compliance within a service provider environment, it's very important to know that responsibility lays on both service provider and end user and customer. So for different kinds of scenarios, this responsibility is slightly different. So for infrastructure as a service, the major difference compared to platform as a service is the encryption of transmission of cardholder data that has to be maintained by a client, by end users. So in case infrastructure as a service is being used, client has to make sure that all of these communications are encrypted at the moment. Also, antivirus updates should happen automatically, and of course customers should handle that. In case of platform as a service, so this responsibility becomes shared between service provider and the customer. And what it means is service provider has to offer that, but customer should also use it for his own services, and he has to be able to control that service provider actually implemented the protection for the layers that are not accessible for the customer. So customers should be able to see these levels implemented in place to make sure that his services are operating correctly and they're fully compliant. And for software as a service, most of the responsibilities fall into service provider hands, so protection of cardholder data becomes a solely cloud service provider task. Managing passwords and maintaining firewall configuration is also purely cloud security provider dependent. Track and monitor all access for network resources as well as regular testing also is being passed over to cloud service providers. So depending on the type of services they offer and type of space you work in, so infrastructure as a service, platform as a service, software as a service, please know that you have to follow and cover several layers and make sure that if customers need to be compliant, you also address it with them and make sure that they can clearly see the enforced security measures. As of the changes that Moria mentioned, these are going to apply to service providers as well. So these are going to change a few aspects of testing and reviews of the certified environment. So, of course, there is going to be a new requirement to detect and report any failing or critical security control of the system. The penetration testing is going to be happening every 6 months, so 2 times a year. Previously, there was a recommendation, right? So, starting from the enforcement date, that's going to be a mandatory requirement. There are going to be a few more requirements on employees and personnel, and the special compliance program within the organization and documented description for encryption. So these new changes are going to appear, and please note that currently they're recommended, but pretty soon, in the course of the next couple of years, they're going to be enforced and mandatory for every single organization. So as we cover the service provider portion here, so let's talk through how 5.9 can cover the PCI requirements. So because we do know that it's very important to maintain your system secure, and it's not that easy to pass certification unless you have a proper solution to help you with that. So Finding Cloud Security is the product that helps achieve multiple objectives of a compliance requirement. And Finan focuses purely on Windows Hyper-V. Hyper-V, it also allows you to perform centralized management through System Center Virtual Machine Manager, provides self-service capabilities through Azure PAC, and new technologies that are coming up this year, like NanoServer and Microsoft Azure Stack, are also going to be supported pretty soon. Along with Windows Server, Finding Cloud Security allows you to cover 8 out of 12 PCI DSS goals for virtual and cloud infrastructure. So this is just 2/3 of the entire set of goals that have to be achieved, and that definitely makes your task of being compliant so much easier. As of the data center and the way it used to be built before, so traditional data centers used to be pretty static, right? So admins had access to all the service. There was enough capacity for all the antivirus scans. So, putting multiple security systems on each physical server wasn't a big deal at that time, as well as deployment process. But in virtualized data centers, virtual environments, Microsoft Cloud environments, virtual machines are very dynamic. So you create new workloads. If you're a service provider, customer may create several hundreds of virtual machines per month. So these all have to be immediately protected, and they have to make sure that these layers can be implemented whenever virtual machine is rolled out and whenever virtual machine migrates within different physical service. So live migration and dynamic nature of virtual system has to be fully supported, and that's what Finding Cloud Security will allow you to achieve. So it's going to keep your compliance and requirements and protection levels very, very consistent independently to what systems are currently doing, so how many virtual machines you create and how many virtual machines are being migrated. Agentless protection that we'll leverage is based on integration with Hyper-V. So we build product from the ground up for Hyper-V, for virtualization. So the best approach that can be used for virtualization is Agentless approach, and this is what we leverage by integrating inside a Hyper-V virtual switch and direct virtual hard disk access to make sure that we can agentlessly protect virtual machines and therefore support the full dynamic nature of the system. Also, it allows you to control the signatures updates and make sure that even malicious user is not able to disable protection when he wants to. So cloud security is a unified security and compliance solution. So it includes virtual firewall, agentless antivirus and anti-malware, intrusion detection system, and network anomalous analysis. So these several layers coexist together and allow you to bring the compliance requirements of implementing virtual firewall, making sure that your antivirus is up to date, making sure you can test your system and note any malicious activities within the single interface, within the single solution. So our goal is to make sure that system that you protect gets all the layers it needs, and the management of that remains easy. As of partners that we work with, so for antivirus, we work with Kaspersky, Bitdefender, or ThreatTrack antivirus engines. All of them are very well known globally, and you receive all the support, all the signatures that this antivirus producers provide within cloud security built in. For intrusion detection system, Cisco Snine for Business is the part of the product, therefore helping you detect all the attacks happening within the system based on Cisco Snine engine, which is very well known in the industry. This is a quick overview on how we analyze traffic and the way we are able to achieve this security in agentless mode for all the virtual machines. So whenever traffic passes to a virtual machines, it travels through a physical network adapter, then it gets to a virtual switch, then it gets to a virtual network adapter inside a virtual machine, and then it gets to a virtual machine itself. So this is the way traffic travels within the virtual system, and if we talk about internal networks, this is virtual machine to host, and private networks is virtual machine to virtual machine. Every single time this is happening, traffic follows the virtual switch on each Hyper-V host. So that means this is the best way and a best measure where you can control any type of communication happening between virtual machines, including private networks and internal networks. So any east-west traffic happening within the system, including two absolutely different virtual machines belonging to different departments or different tenants within the system, can be completely isolated and microsegmented on a virtual switch level. This is agentless approach, and it also allows us to avoid any spoofing techniques that may be potentially used by attackers. A virtual switch allows us to clearly see every single operation coming from a virtual machine, every single packet, and therefore clearly state what virtual machine was trying to perform an attack or what was the subject of this attack. As we are doing that on a virtual switch, no blind spots are possible. Therefore, external, internal, and private networks are all protected. If you go and drill down into the layers of security that defining cloud security offers, this include host protection for physical network adapters connected to a virtual switch. We are able to provide firewall detection system network anomaly detection. Automatic enablement of security layers on each virtual machine whenever deployment process is happening. So you deploy a virtual machine, and Final Cloud Security can automatically enable security measures for this newly deployed workload, therefore maintaining the security of your system at the consistent and very high level. Virtual firewall happen on a virtual switch, so it analyzes traffic flow and allows you to completely control what has to be allowed and what has to be blocked. Antivirus detection on network level, that's based on Kaspersky, Bitdefender, or ThreatTrack antivirus engines. This analyzes HTTP traffic flow and allows you to agentlessly detect viruses in the network. Antivirus scans that are happening agentlessly and therefore saving you a tremendous amount of time on performing scans, and these scans are happening up to 70 times faster because they use change block tracking techniques. These techniques also allow you to avoid antivirus storms and therefore put up to 30% more virtual machines on each Hyper-V server. Network intrusion detection system is based on Cisco's North for Business and analyzes every single communication to make sure internal communications are protected as well. Network anomaly analysis creates a baseline of normal traffic behavior for each of your virtual machines, and in case the sensitivity level shows you that virtual machine's behavior is way beyond its normal parameters, you're going to receive a notification alert. So anomaly on a virtual machine that usually sits and say sends 10,000 packets a day, right, and suddenly it starts sending 200,000 packets a day. So this is definitely going to be normal behavior for this virtual machine, and if that's not planned, you want to detect it. And of course, whenever you're compliant and when you run the test, and this allows you to keep your testing running on a very consistent manner. And of course, extending all the logs to external system, the analytics system, is the way you can analyze all the logs and aggregated states, virtual machines, to find potential security issues. For the service providers, we do have a free extension to our product that's called Final Cloud Security Asia Pack extension. This allows to provide security as a service for cloud service provider customers, and this allows tenants to easily manage security policies through self-service portal. And that utilizes our Agentless performance mode and a very, very straightforward way of integrating that inside Asia Pack portal for every single service provider, and especially running infrastructure as a service for their customers. With that, we are going to reach the demo section here. So Final Cloud Security's interface is meant to be very easy to use and very intuitive when you start talking about different security layers. So all the security configurations, all the security measures are combined in a single interface, and you just switch between tabs to access each one of them. So even if you don't have a thorough security experience, Final Cloud Security is going to be a very straightforward solution to go through all the layers and make sure that they're properly configured. So first of them, and this is one of the very first PCI DSS requirements, is related to virtual firewall, and this is the one that operates in a virtual switch level. So when virtual firewall is enabled, virtual machines start following only the firewall rules that got created within cloud security. So this is the most secure approach. So whenever you enable a firewall on a virtual machine, this becomes completely isolated from any communication happening on the network, including communication from nearby virtual machine. So it's very safe to be running different kinds of workloads on the same infrastructure, on the same service, even on the same LANs and the same VLANs, because cloud security fully supports that. When you create firewall rules, cloud security uses standard networking methods, but it also uses the unique methods that are available only for Hyper-V and virtualization that are related and based on virtual machine identifiers that are absolutely unique for each virtual machine. So whenever a rule is being configured, you can select a virtual machine out of this selection list, and this is going to create a firewall rule based on virtual machine identifiers. And even in case end user of the virtual machine or some malicious utility tries to change IP addresses at a virtual machine, this rule just keeps working. It is very robust, and therefore it allows you to maintain security measures taken inside the virtual infrastructure on a consistently high level. Also, virtual firewall allows you to collect statistics and access the connections table of each virtual machine without the need to go inside. Therefore, testing procedures become so much easier and allow you to review the system and each communication of each virtual machine throughout the single interface. Every single virtual machine can be automatically protected by security measures, so default virtual machine security can automatically enable multiple security layers for each virtual machine, including virtual firewall, intrusion detection system, network traffic scanner, network anomalies, and antivirus. So every single newly created virtual machine can be automatically protected, automatically added to kind of a sandbox group, or a DMZ zone where it's safe for the newly created system to run. So whenever your very dynamic workloads migrate between hosts, these are fully covered, but even if new workloads appear in the system, you are still protected because every new virtual machine gets its security measures. Therefore, your compliance status is going to remain very consistent throughout the environment operations. As of detecting anomalies, this is happening with we're creating the baselines for each of your virtual machine, and you're going to be able to review the reference numbers, so the real data that we collected from virtual machine based on statistics, created the baseline for you, and then you can analyze if current behavior is way beyond what it should be. So network anomalies show you reference numbers, but of course all these events are going to appear in centralized dashboards for notifications. They are going to be fed into a centralized login system, and you can also set up alerts via email. Intrusion detection system is based on Cisco Snine, and this is the one that detects attacks for you, and therefore you can clearly see what source was trying to attack your virtual machine and what virtual machine exactly got attacked. So it's invaluable to make sure that you have this testing capabilities, and of course if any of the attacks is happening, network anomalies detection as well as intrusion detection system are going to help you to support attacks within the environment, including the internal events, so when internal virtual machine is trying to attack other system. And antivirus, of course, so this is the multi-layered antivirus protection that is based on Bitdefender, Kaspersky, or ThreatWork antivirus engine. It allows you to perform network traffic scanner tests, full system scans based on change block tracking that are happening as fast as just several minutes, and real-time protection inside virtual machines with optional integration service in case a memory scanning and inside virtual machine scanning is required. So all the layers are available, and for PCI DSS, of course, you're going to use all of them to make sure that you are covered from every single aspect of the standard. Finally, Cloud Security also provides integration into System Center Virtual Machine Manager, so you can perform centralized management of your entire infrastructure from a VMM, and also manage cloud security, so security layers of your system through the single interface through a free add-on for System Center Virtual Machine Manager. And as of Asia-Pac, this is the way to provide customers with self-service capabilities and make sure that they're able to create firewall rules for the system inside the Asia-Pac self-service portal. So add an IP rule. It's very straightforward. You can just go and add it with few clicks inside the system. So no specific knowledge is required. So even if customer doesn't have a thorough security background, he's able to do this in just in a three steps wizard, which is very straightforward. With that, I'm going to wrap up the product presentation, and I'm going to switch back to our slides deck to go through comparison of HANA Cloud Security and make sure that we have some time for your questions that I'm pretty sure many of you have. So when we compare HANA Cloud Security to other solutions, we are purely based for Hyper-V, so we create solutions for Hyper-V only. And this allowed us to achieve a way better performance and way better just technology for Hyper-V virtualization and for Hyper-V virtual machines, because we work with a very strong collaboration with Microsoft here. And having multiple engines to choose, agentless levels for antivirus, these are all the ones that you're able to utilize within cloud security. So agentless firewall, agentless intrusion detection system, these are all very specific, and these are going to be available when you install HANA Cloud Security product. So with that, I would like to give you some time for questions. We have another 5 minutes to answer all of them. So if you have anything you would like to clarify throughout our session, anyway, we cover compliance specifically for your environment, please post your questions in the chat box, and Morgan and myself are going to be happy to answer them.
All right, and let's go ahead and go through a couple questions here. So the first one I have, I think this is a good one for Morgan here. This is a question comparing a virtual network appliance to a physical network appliance. And the question is, does a physical network appliance give me the same type of protection in a virtualized environment that I would get similar to something like 5.9?
Yeah, thanks, Simon. Yeah, the virtual network security appliance, or the network appliance firewall, or hardware-based firewall component that sits on the network will be able to see traffic that's coming inbound from to the network component, the network cards on the host themselves, so that that northbound traffic will be analyzed. Where those perimeter type approaches, and usually the perimeter now is at the data center layer, or there's a perimeter at the data center layer, and there may be another one at the public access point or private communication lines. That's going to handle that traffic that's coming in and outbound through there. But the major area where you're lacking coverage is communications between hosts themselves. So, for example, you may have a workload that requires to go out to a database within the data center itself, and if that physical appliance is sitting outside the data center, it's not going to see that traffic that's going between that host. And even more commonly, if you add another layer inside your data center and firewall between all your hosts, you're missing that traffic that also may go east to west, which was what Alex was talking about a little bit earlier in the example of how the traffic moves. That's happening at the virtual switch layer. It doesn't even hit the network cards on the hosts themselves. So that's going to be an exposure that you have, and this is especially a problem if you have an insider that's compromised one of the VMs, be it through malware or hacked in through some other way, and then uses that VM to launch attacks to the other information, other areas where the cardholder data may reside, or the environment of the host that are, or the applications that are processing it. So, or you may have that also in a service provider scenario where it's easy for them to get in because anybody can gain access into their own VMs, but if are trying to use those VMs maliciously or use another customer's VMs to attack those VMs internal to the host, that traffic will never be make it out of that virtual switch and be analyzed. So that is a risk point that you need to address, which we do through our solution set at the virtual switch layer.
Thanks, Morgan.
Hopefully that covered it.
That was great. And we have one more that comes in, so maybe we'll give this one to Alex here. And this asks, if I acquire 5.9 cloud security, does this guarantee that I'm going to meet PCI compliance?
Oh, that's a great question, actually. So when we talk about cloud security covering PCI DSS requirements, this applies to several layers of the standard. So there are 12 main goals that you have to achieve when you have to be compliant with PCI DSS. Some of them are even related to physical layer. So finding cloud security won't give you a guarantee that you're compliant, but along with Windows Server, it's going to cover 8 out of 12, so 2/3 of PCI DSS compliance goals for the infrastructure. And that's very important to realize. So when you're going to be assessing your environment, there is a self-assess list, right, that you can run through, and then you would also use a qualified assessor to make sure that you're compliant. Finding cloud security will help you cover the layers, but there are a few other steps that you still need to take to make sure that all of the checkboxes are met.
Great, thank you, Alex. Thank you, Morgan, and thank you to all of the rest of our attendees that joined today's webinar. We hope that you've learned a lot about PCI, and more importantly, the different ways that you can help achieve PCI in your own Hyper-V environment or Microsoft Cloud. With that, we are going to conclude the webinar. We'll send a follow-up email out to you in the next couple of days after the video has been edited along with links to the presentation and our different white papers and other great resources that we have around PCI compliance. Thanks again for attending, and have a great day. Goodbye.
Thank you. Goodbye.
Thanks, everyone.